So we are going to do a little bit of 14.1 for a few minutes. Um, so yeah, this problem sucks. I don't know why, but we're going to figure it out. Choose whatever domain below. Well, we want the inside to be greater than or equal to 0, right? So in a way, it's like I want to solve for x and y, and let's have fun with that if that's okay. Actually, you know what? Pause. I bet. Yep, there it is. It's don't overcomplicate it, right? For domains with this kind of thing, we're saying that the inside's got to be greater than or equal 0. I just said that, and I was like, well, let me go solve. No, we don't need to solve. It's already there. Is that okay so far? So essentially, what you're saying is the inside, has to be equal or greater than 0. Yeah. Okay. Because we're not doing imaginaries anymore. You'll never see him again. Not in this class. Yeah. Well, we don't think about that here. So right, I mean, we know square root of 0 is 0, and that's fine. We also know that positive numbers are fine, right? Square root of 4 is 2, and all that stuff. But if you go negative, then you're going to get i's, and that's not what we're doing here. Okay. As far as graphing it, though, this is very strange. I need to look more like this. Okay, so I have, and I would like to do Desmos graphing to make it like super fast and understandable, but I want to also do it by hand because that's what we have to do, I guess, sometimes. Move this over. I think I'm going to move the other guy over too. Yeah, let's move this guy over. Oops. Notice that I'm retaining the alligator position as long as I'm not multiplying or dividing by a negative number. That is a small key to all this. And so I'm saying that this is my line. Like I basically have a line where I start at 4, and then I'm going to do up to over 1. Right, there's my line. And I'm saying I want to be greater than that amount. So like I want to be above it. So A, B, C, or D. It would be B because there's a solid there too. Because we said it had to be also equal to 0, the line itself also is included. It wouldn't be D because those are dashes. Very good. Oh, okay. So the dotted lines are if it like doesn't touch it. Correct. Well, it's a line means that it's okay. Yep. Yeah. I suspect that if we get an ln, then we'll use the dashes. Okay. Or if we have a division by 0, that would be more like a dash in the middle of a field of yellow or something. We'll see. Yeah. We'll see what it looks like. Right, it would be a hole, exactly, instead of, yeah. So how do you graph a hole? It's very, very hard compared to the other stuff. See, ln, I called it, didn't I? Right. Oh, well, you mentioned Desmos. So yeah, real quick, let's do Desmos, and I want to show you you can actually get the full answer every time. Again, I don't know if I would recommend it. I'm going to say maybe, but you're putting that in. Notice, I mean that. There's your answer, right? It was just that easy. But notice I didn't put the whole square root, blah blah blah. Right? I'm looking for the domain, and so like on this particular case here. So not that one. This one here. What should I have for the inside? It needs to be what? Greater than 0. Strictly greater than 0. Right there. And so I'm going to type that in. Strictly greater than 0. And this makes it so much easier. I don't like these questions because of the multiple choice stuff, and therefore you'll probably not get that on. Oh, just strictly greater than 0. There you go. You'll probably not get that on exams. I'm very sure about it. But there you go. So A, B, C, or D. Boom. Done. Is that okay that we can like just type in what we're wanting, I guess? But to do this one by hand, it's not really that bad in the end. we know that we have a circle, and if you move that over, you would get a radius of 9. So then again, retain the position of the alligator unless you're multiplying or dividing by a negative number. And so I'm saying that my x squared y squared, my r squared should be greater than 9 squared. My radius should be greater than 9. So again, we got a radius, and I'm saying more than that. But also notice it's not including 9, is it? So that's why we've got dashes. Just different ways of seeing it. All good though. I don't mind waiting. I'm totally fine. Love waiting. That's fine. Doodling is good too. So things are getting a little interesting here, right? But think about what we need for domains. And this is going back to algebra, which I know you all remember, right? Chapter 2, section 4. Yeah. Questions number, 3 through 9. You got this. So I'm looking for division, square roots, and ln. The ln is a new one for us, right? But is sine having a problem with our domain? Never. I mean, this is always -1 to 1. Everything's fine. It's this part. And so look again, we got a circle, don't we? What's my radius of the circle? Yes. So I'm saying that the radius of my circle cannot be 7. And only that. Well, even then, notice that I could get something that's negative down here. Right. Kind of weird, isn't it? So how would I express that here? I'm saying it's like not equal to. Oh yeah, there you go. Exactly. In the field, yeah, exactly. Just like we talked about earlier. Perfect. Yep. Cool. It's very weird. Yes. It's like you cut it with scissors. You can put it right back, but. Well, good point. Oh, I did not know those. That's cool. Not while we're recording. Okay. Right. So again, I want the inside to be greater than or equal to 0. Is there just a quick version of that somewhere around here? Probably. Yeah, it has a lot of blah blah, but it has that greater than or equal to 0 part. So like what's going on here is that they factored it, didn't they? That's all. And then checkerboards. No, I don't know. I actually don't know what I would put for this. You would put Desmos. I love that. Great idea. So again, we're only doing like the inside is greater than or equal to 0. Ah, it is a checkerboard. Bloop. Pretty cool. Yeah. I mean, as far as why that's happening, we can go through and figure it out. Right, that's true. Right. Notice that my answers are basically x equals plus or minus 3 and plus or minus 4. And so what does it look like to graph x equals 3 or x equals -3? They're just vertical lines. What does it look like to graph y equals 4 and y equals -4? So we're already kind of designating this checkerboard pattern, right? Just by factoring. And then why would one or not, why would this work and not that? You literally plug it in. Like plug in 0, 0. Would that give you a good answer? But yes, 2 negatives make a positive. We're fine, right? Yep, exactly. One by one by one. Yep. Or just multiple choice. And so, because if you look between them, really, it's this one's the solids, and you got the checkerboard. We know that. We're good. Correct. Correct. I think that would be just if there was one of those. Only the x or y squared or something. Or kind of like mush them together. But when they're separate, so this guy right here. So again, I don't like the level curves. I think that these are just kind of junky graphs, but we have to talk about them, of course. You take C and you plug it. Oh, you plug it in for Z. That's what you do. Yeah, C and Z are the same thing. Because if you notice right here, f of x, y is Z. Z equals C. So yeah, just plug it in, graph, plug it in, graph, plug it in, graph. And I mean, really, to make this so much faster, we should just be graphing this. So -2. You know what? No. This is good. This is good. I'll do it manually. So there's one. And then we do it again. Right? If I could type. Oh yeah, there's so much problem going on here, but yeah. So how do we do this even without graphing? It's super easy. You literally plug it in and you make a line, right? Y equals mx plus b. And they even say, hey, this one's for -2. Did you get that? Like, I mean, it's like straight up. They're not trying to cheat you out of that. So, yeah, I'm okay with that because yes, the extremes are what they have on their graphs. Yes, I understand. Yes. So, yeah, we're gonna get circly stuff, right? But are we getting circles or ellipses? Both of them, though. Circles. We're definitely thinking circles. One of these two guys here. Whenever I plug in a 0 into this, would I get, what would I get for x and y? You'd have to, because they're both squared, so they have to be positive numbers. And then you're adding them. So like you got a positive plus a positive, you have to get positive numbers, right? The only way to get 0 would be as if they're both 0. You can't have a negative in there. That wouldn't change anything. And so yeah, I would say this guy is probably the answer. Circles with a 0 in the middle. Right, that would be more elliptical. Exactly. Or wait, you said divide by x. Yeah, yeah. It'd also change it radically. But again, Desmos Graphing's our friend here. I don't want, I mean, these are not really good test questions because they're just kind of bland, but yes, they'll keep popping up. So plugging in 0. So again, I just keep doing the same thing. Well, that was helpful. Like, are you serious? Okay. Okay. Well, I guess that was nothing. Plugging in a 1. There you go. And so just to see them like duplicating. There it is. You square root of 0 is 0. And then, well, actually, you would move the 29 over, wouldn't you? See? But there's nothing there. Whatever. Moving on. It's multiple choice, right? It's circles. There we go. Don't overthink it, because there's way other cooler problems than this in life, right? Again, more of this blah, right? Wow, 1 of 6. I don't want to have to do that. What would be the domain for this guy? You know what? Hold on. I want to do a harder problem. Are they going to do that 1 out of 6? I want to do like a hard problem. Okay. This one. This one looks fun, doesn't it? Yeah, that's the thing. I don't want to do it, but I want to for you guys. Domain from the inside, right? Got to be greater than 0. D indeed. Cool, cool. So the range, this is the output, all right? You can't think Y values anymore, right? And you can say Z, but that's confusing. It's the output. I put numbers in, all these different numbers, and they say I'm putting in positive numbers, essentially, that kind of thing. What output will I get from ln? Yeah. Oh, it's definitely going to infinity. But would I have a negative infinity? That's going to be an interesting thing.
So using the same logic as the last question, yeah, we don't deal with eyes.
Ooh. So why is that? This is a fundamental thing from way, way back in the day. Do I have negative values? I know it says undefined, but that's just Desmos. This keeps going forever, doesn't it? So we do technically have negative infinity all the way to positive infinity. And again, we're just saying ln. What is ln output for us, right? Correct. Yeah, we're putting stuff in, but I want to know what.
So that's negative infinity x, y, positive infinity x, y.
Yes.
Considering both the x position and the y position.
Yes.
As opposed to, like, if you did this before where it was only x, you would say 0 to infinity because you're considering the x position.
Possibly. Definitely for your first one, possibly the second. Okay.
I'm not sure if that explains.
No, the first part I totally agree with. Yes. Very good. Cool, cool. So yeah, think of it like output, right? Without going too far, I want to go back to one of these other oddities because like this guy here, he looks simple, but he's strange. So do I have any domain issues? Division, square roots, ln's. So what do I put? All, every, each. Yep. What would be the output? All, everything. Again, if I have, I know, right? Negative I. Yeah, it's not negative I. You're right. You're right. Oh, and there I forgot the comma. Yeah, if I put in really big positive numbers, I'm going to get positive numbers. Put in some negative numbers, I'm going to get negative numbers, right? Anything's possible. So that's kind of what the range is. It's like, output for that one. Going back to this guy. So level curves. I hate these. I don't like how they're like words. But again, we're looking at the inside. Greater than 0. What's the shape of this inside thing?
It's an ellipse.
Almost. Do we have ellipse as an answer up here? Choose the best option without ellipse. Circle, yes. Right? The reason why is because they're the same coefficients for x and y.
Okay.
Circle.
Okay. I'm thinking back to conics where it's like where you have like one is the ellipse and stuff like that. Yeah.
You know what? It's true. Ellipses. Wait, how does it work? That some ellipses are circles. All circles are ellipses. Something like that, right? Yeah, it's something like that. You're fine. I get you.
How all boxes are rectangles, but not all rectangles are boxes.
Squares.
Squares.
Exactly.
You get the idea.
I do. So yeah, the ellipse, well, the best idea would be circles, right? Circles, again, radius, what? Yeah, that's what I'm thinking too. Now, what is the C doing in here? No. That's way too complicated. I'm thinking this guy here. No. Oh gosh, even worse. Okay. It's not hyperbolas. Point at the origin only when this. So if I had the whole thing equal to 0, I don't think you can even make it equal to 0. I don't like that one. A point at the origin only when C is 2. Maybe that. At least one of your answers is wrong. What? Just A? Okay, so my first initial was this guy, right? But then it needed to be for all C, and that makes sense with what we just had. So I was thinking, oh, we got to be positive. No, LNs have negatives too. We just saw it has right here negatives, right? And that's the thing. This is equal to C. Z equals C, the same thing right here. Can I get a negative right there? Yes. So can I have negatives? Yes. There it is. Okay. Well, now we know. Domain have a boundary. Man, this is dumb. So I'm sorry. I'll record that. I don't care. I have to put these in because this is what is available to us. Level curves are cool. These questions are not. Does it have a boundary? Well, I mean, yeah, it's that circle thing, right? So, yeah, I know, right? 4 minus x squared. Hey, how'd you get that, Chad? You solve for it, and they said it has to be y squared. They said it has to be y squared. You can't go back up and look at the darn thing. So it has to be y squared. Move the x over. Oh my gosh. So just, ugh. But now you know. Now you know. Okay, so open and closed. Open is more like the dash lines, the dashes, and closed is like solids. And ln would have to give me dashes. I think that's what we said last time. If you go up to the very top here, this guy, strictly greater than. So we would have dashes, not solids. Correct. So bounded or unbounded, just real quick on this, okay? So we're saying that the radius has got to be greater than 4 when we move it over, okay? So the dash should say that it's open, okay? But notice, like, this goes on forever. Unbounded. It's my thoughts? Okay. Gosh, man, I get in trouble so much for this stuff. I will not say that that's the appropriate way to think about it, but it worked this time. If you really want to know bounded, unbounded, open, closed regions, take advanced analysis at TMUCT or some other place, and you'll learn it all so well. Cool. We're gonna just get by. I mean, there's deeper definitions for that, but yeah. Pictures. Can you multiple choice it? These are the worst ever, aren't they?
Wouldn't that one just be the
C.
C?
Yeah, it doesn't have any bumps, basically. Yeah. Yes. It's the map contour. If you were looking at it as a map, what would its hills look like? You like A? Because there's a lot of different bumps and stuff. Yeah. Lots of hills and valleys. True. You like C?
Actually, it could be B.
Go away. Oh, I can't choose it now. Yeah, it's either C or B. So this one's kind of interesting because it goes down or up really high. And I want to say that looks like it's going down really quickly, but it might not. Yeah, like a bowl. But to me, like first glance, it looks like it's a bottomless pit, which is what this is indicating, by the way. Some other things that indicate it. Look at this, how there's nothing going on in the inside here. That's not by mistake. That's a plateau. And you see how this right here cuts it off? It's like that's a plateau right there, isn't it? Still don't agree with it, but there you go.
Well, the thing that confuses me is you can't tell if it's going up or down. Just
Yeah.
circles inside circles.
Yeah. Oh, and let me just click this so I can kind of like, come on, rotate.
That would make it a lot easier to actually understand.
Yes. Oh, these are just graphs of the stuff. So like I think we've done this before. It's been a while, but like, ellipses, circles, parabolas. These are
This
the,
is like 12.6.
yeah, very similar in that idea. Yeah. These are fun. This could be on there. This could be on exams and stuff, but I'm not. We can come back later if you want me to. But that's not the same as level curves. They're just doing their own thing. Yeah, I can guarantee you this will be on an exam somewhere.
No, that would be the height.
That's definitely a tube
Yeah.
because it does not have a y. So y could be anything.
What I said was it was a circle. So
True, it is a circle. That's a circle, and yes, we just don't know what y is.
I
So,
was wrong. I meant to say sphere.
well, as long as you admit it. Yeah. Anyways, so the almost the same principles, right? Odd man out and all this other stuff. Same style. I'll let y'all figure that out. It's fun. Those are the fun questions. Cool though.
Yeah, sir.
Okay. Yeah, I didn't like the level curves either. But we don't have to keep doing them because we got more of this. Yay! Oh. Now we did some of this directional derivatives, gradient stuff already.
Yes, I believe we're on the second to last one.
Sweet. So just as a quick reminder, this is our formula, but I want to, and I always add divide by magnitude of u, just because it never really is the unit vector. They just give you something random, and so like guaranteed you're gonna have to do something about it like that. Did we do this one yet?
Yes, that was the last question.
Okay. Oh man, can we go back to this one? So, you know what? This is a really cool problem. Okay. Before we get into the analysis of it, I want to graph it to see what it looks like because honestly, this thing is kind of messed up looking. Do we have division?
Yes.
So we're going to have a problem, a domain issue error somewhere on this. Okay. So let me graph it. I just want to look just for fun. This is just for fun. And then I'll explain what we're going to be doing in just a second. It's going to help there. 3D. Got to do the 3D stuff. So we got Here's a problem. When I'm graphing, I got to have z equals. See the problem now?
Yeah,
W equals. There's no way they're gonna let me do this. they're like, nah. Well, we're gonna have to do some math here. Yeah. Let's go through a concept. I thought that I could just show you, but that totally failed. So that's fine. I wanted it was just for fun. Let's talk. Go ahead.
I was just wondering if you could solve see if I just like
We're gonna do stuff like that, but I just want a general concept. So here's a general concept for you. Let's do something like a thing like this, and this will be 3D. So I'm kind of like making it a waterfall. No, right? So it's like a path that's going up or something, right? And I'm looking for. I'm going to use a different color here. I'm looking for whenever the directional derivative is at a maximum or a minimum. And you can see that right here most rapidly. Yeah. So that's or I guess like least rapidly if they might say that. And so if I'm like right here, let's say, then it would be this way, right? Or this way. Going up or down would be the maximum whatever. Right here on this point, it would technically be right here and here because I'm fixed at a point and I want to know what direction. But now, what if I had a sphere, right? So I have a sphere and I pick this point right here and I'm saying, where's the maximum directional derivative stuff? Well, I mean, yeah, in a way. So, and this is 3D, right? This question technically is 4D, so it's a little weird, right? But think of it more like you're going up or down, strictly altitude. So altitude would be going this direction and that direction. Yeah, like you're maximizing your altitude. You're going higher or lower. Yes, and again, that's just because it's 3D. There's a lot of that going on. But there's alternatives. Couldn't you walk like this way or this way around the sphere, and it wouldn't be as much altitude, right? And so another version is like a hill, and I'm just gonna make like little hill stuff there. So if you're standing on the hill right here, and you want to know, I want to get to the top, so you want to go towards the top, but like the top is not always center. What if your origin's right here, right? So your direction isn't always to the 0, 0, it's to wherever that point would be. Or you could walk around it. That would be the minimizing its directional derivative rapidity, something like that. Anyways, so what we need to do is have our directional derivative for any angle, because that's what's differentiating between these guys. And I know I'm just using calculus words now. Differentiating. What's different between them is my angle theta, right? I could have one here, I could have one here, I could have one there, I could have one there, and they're all stemming from this point. How do I know the difference? Theta. Cool? So that's the key little moment here. And if you look back at this problem versus the last one, this one gave you a unit vector. The one before it gave you a unit vector. Okay, not a unit. It gave you a vector. The one before it did not ask for that, so it didn't matter. They're giving you vectors, but here there's no vector. So I'm going to create one. It's cosine theta, sine theta. And this will tell me any theta that I choose, how high it'll be going, what direction you're going, that kind of thing. Okay, so that's going to be the key trick here. I'm going to ask, is that a unit vector? Magnitude equals 1? Is that a true statement or not? Yeah, because it's a circle, right? Cosine, sine, x and y. What would be the radius? 1. There's a 1 right in the front, right? There's a 1. So unit. This is literally the unit circle. Like back from pre-cal, there's your unit circle. It's a vector. Cool. So we got this guy. We'll plug the point in here in a minute, and then we're going to do some derivatives with this guy. So just as another reminder, directional derivative of u, in direction of u directional derivative of f in terms of u or something like that is my gradient of f, right? Grad f at p naught dot u over magnitude of u, essentially. We don't need the magnitude u this case, but I have to plug in p naught. Could you imagine having x's and y's and thetas? It's insane, because you would be asking, all right, I want to know the whole hilltop here, every point, every direction, give it to me. And it's just insane. So you have to pick a point, and then that's where you get numbers, and then you can start finding what direction you want to go, okay? So that's nice of them, because otherwise that's inhuman, right? That's like, leave it to a computer. So now we have to do some math. Yes, I am leaving it to computer. Exactly. So I need some derivatives. And again, just a reminder, it looks kind of like this, right? Because this is kind of wonky. This is really what's going on. Derivative in terms of x, what would I get? Yes. And that's it, right? For y, what would I get? So, yes, another way to think about it is this guy. So I'm bringing this down and I minus 1 from it. So it makes it negative, but then I'm minusing 1 from negative 1. 1 minus 1, or I'm sorry, negative 1 and negative 1 make it negative 2. And then for y, what else would you have? Good. And then for z, perfect. Change my colors. So that's good and happy, but without plugging in p naught, things get really hairy. So let's plug in p naught. I would get 1 over 1, negative 2 over 1 squared minus 2, negative 1. Is that negative 4? Okay. So that's my my grad f at p. Hi, guys. Yeah. Coffee? Coffee. No, I don't care. I mean, I'm being recorded. You're on YouTube now. You're famous. That's funny. So I have my direction. Well, I'm sorry. I have my gradient of f, and now I need to go and dot it with my unit vector, right? So dot unit vector. So that would be 1, 4, -1 dot cosine theta, sine theta. Dun dun dun. Right? So now we're in a conundrum. I was thinking 3 dimensions. That's all I ever thought, but now we're in the 4th dimension here, and now I'm kind of scared. Oh, yeah. Yes. Yes, it is. Yep.
Oh, that's gonna suck. I guess I'll be watching videos.
Good thing I made them on YouTube. Yeah, exactly. Making it right now. All right. Anyways, so yeah, what can I do? I thought that we had this. This all made sense up until this point. And I gotta say, I literally am confused myself. So I want to read it because they keep like duplicating this. Look, most rapidly. Oh, increases, decreases, direction, direction. Let's just read it, and I want to see more. So it says direction of this function increases most rapidly at this, or this. They're giving me a vector. Yeah. See you later. It's not a theta. See, they should be asking what direction, and I say a theta. But they're not giving me a theta. They're giving me 3 vectors. So here's an idea. What if I were to abandon this? So sad. Like we talked about it, we had a great time. What if I used X, Y, and Z? And I don't like this. I don't. I totally disagree with it. But what if? What if I had to? Because what's going on here is I'm saying, hey, just give me an X, Y, and a Z. And so if I dotted those, I would get whoa. If I'm dotting them, then I would get X minus 4Y minus Z, right? But I'm still having a conundrum yet again because they have a vector answer. You see? So I don't like that either. You know what you do in these cases? You get it wrong. And you go see what they got. Duh. So, please.
Couldn't we do? I believe it was something we did in section 12, where since we had the x, y, and z, we could make a vector plane. Where we have like the original point, so that would be like you're just plus 2
Okay.
1, and then you have your vector now, which is the x, y, and z, which you could change into like t's, something like that. Could we do something like that?
Maybe. I mean, I'm cool with these. Let's see what they got. Watch, this can be something silly and easy. It's like you overthinking it, Chad. Okay, let's analyze for a second here. 1, 4, 1. Where have I seen that before? What's the only difference here? Notice there's some. Go. Yeah, I wonder where that came from. So yeah, let me erase all this stuff that didn't matter, apparently. Way overthinking it. This is why okay, never mind. It's just a pilot. It's fine. So my magnitude for this would be square root of the squares, right? That's what, 18? Square root 18? And if I'm being funny here, right? Because isn't that 9 times 2? I know. You got it, Lee. You're like that. Looks interesting, Chad. We did it. Yay, we did it. What does that mean? I don't know. But we did it. Yeah. All you're doing is what they were asking for was your gradient divided by the magnitude. They just want a unit vector, I suppose. Isn't that just mean? It's too easy. It's too easy. I don't like it. I really wanted a difficult problem here, and they're like, nah, let's just go ahead and not. So increases versus decreases. And if you go back, what's the only difference between these? You're changing the signs. If we go back to our previous three-dimensional examples, I said this way versus this way. Yeah? I said this direction versus that direction. They're always off by how much? How many degrees between the maximum and the minimum? 180 every single time. And if you were to spin around 180 in 4 dimensions, you would basically say switch your signs. Gosh, man. Yeah, I don't like this now. You're making my head hurt. And so it says the derivative of this. So they said the direction. Now it's the derivative in the direction of blah, 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 blah. Well, those are just the magnitudes again. So, yeah, kind of disappointing, actually. I have to say, I actually put this one in because I thought about the theta angle thing. I was just so sure. Finally, we get to talk about this cool concept. And then, no, they make it a 4-dimensional, and they don't even really ask about it. So you get what my issue here, right? So I don't like this problem at all. I don't like for the workbook. Getting it done on the homework's whatever. But it just was not enough discussion. And I want to go to the homework now and see if we can find one with theta. This one's an easy one, and then we're done. Are y'all okay with this? Can I go to the homework and finish it later?
Yeah. One question.
Yeah.
Before we move off this.
Yeah.
So essentially, if it increases, we leave the numbers as the same. If it decreases, we multiply by -1.
The idea again is that if I'm gonna make my little hilltop again. Is that okay? So like if I'm at a point and I want to go towards the top, the opposite would be going down the other way, right?
Right.
You're always 180 from each other. Opposites. Switch your signs, you're done.
Okay.
It's more of a concept thing.
Okay.
Yes. Very good. Yep. Okay, let's do this one, and I want to go to the homework and like look for some cool problems. Or should I just stop right now? This is an easy problem. I looked at it earlier. So it says the equation of the tangent line. There is a formula which we've already done. Dy dx is negative f sub x over f sub y. As long as your capital F is equal to 0, essentially. That's like a given, I guess. So I want this, and I want to find what my cap F would be. Take a guess. Oh no, this is way too easy. I want it equal to 0. No integrals yet. I know it's a capital for no reason at all. Done. Wow, that was it. Now I am going to take derivatives. That's what the little subscripts mean again. I know it's been a while since we did this. In terms of x, exactly. So, go ahead. Just y. What's the derivative in terms of y? Just x. How did you know? So yeah, the derivative of in terms of x would be that y right there. It's not. And the derivative in terms of y, just x. Okay? Dy dx, gosh man, that reminds me of a slope. My goodness. We've done this before. Negative y over x. That's my little m. But more specifically, because we're having to plug in the point that they have, notice that they actually give us a point. That is my x. That is my y. I'm going to plug it in. And so then I have negative of a -5, I believe. Yes. Yes, the whole thing turns to a +1 for my slope. So yeah, I'm not even answering the top part. because I don't really care. I need to get the bottom for sure. But I got a slope of 1. And they said the equation of the line. Okay? Tangent just means we took a derivative. Did we just take a derivative? All right, we're good. So then I need an equation of a line. Y minus y1, mx minus x1. This is old school now, right? What would be my y? The -5, exactly. 1, and then a 5. 2 negatives make a positive. -5 on both sides. And that's your answer. Yeah, y equals x minus 10. And I'm going to just show and verify. See? That's all it was. That was all it was. Given that that's my answer, and I'm looking at all of them, and they all have that, by the way. Notice they're crossing through at 10. Every one of them. Maybe I could have thought about that too. Just a thought. The only options for lines were that equation. So yeah, that's my answer for this one. So now which one are we talking about? Really, we need to go back to the original function. Is this a circle? Not at all. That's not a circle. So these guys are out. Okay? It's going to be it's a rotated hyperbola, by the way. But blah, blah, blah. It's one of these guys. Now, which one would have a what is that vector? Is that the only difference? Give me a second here. Because curve sketch together with grad f and a tangent line. Okay, grad f. Grad f. Here. Let's do it. I know, but let's do it again. So what's the derivative in terms of x? And the derivative in terms of y is? Sweet. Oh yeah, what is my x and y? It's, there you go. So that would be -5. This, again, don't get confused right here. This is my first I x component, j component, y values, right? I'm going -5, 1, 2, 3, 4, 5, and then positive 1, 2, 3, 4, 5. So it would end up over here somewhere, right? This is like a point, -5, 5 point, right there. Go ahead. They did. They did. Notice that I chose to start from the origin. That's not correct. You got to start from where it's touching. Yeah, you're just shifting it down. So it would be this guy right here. But it's the same distance. Same distance. Notice what's the distance from here to here is way more than 5. It just needs to be 5. Exactly. Yeah, we can find the magnitude and da-da-da-da. Yep, exactly. There it goes. So, yeah, lots of blah, blah about it. But I think they just made it like a little bit for no reason. That's how I describe it. But the math, though, is not hard, right? Okay.
A little confusing, but it doesn't seem to be too bad.
It's weird. The math is not hard. It's where you put it, right?
That's very technically what I'm
Yeah, like it's easy to like take a derivative, but like where do I take a derivative? Why? Real quick, since we're still like up, we have 4 more minutes. I want to see if they just have one of those cool, gosh, man, my math lab. I want to look for one of those cool problems. Yes. There's no way I'm doing it. It was 14.6. Thank you. I know that we're ahead, but I don't want to go that much ahead. So I'm looking for one with the theta angle things. No, that's the same stuff we just saw a second ago. Notice again, I'm wanting. All right. I like this better. You see how it's a 2D? I can actually graph this. So I'm not gonna solve it. I'm not gonna finish it, but I want to talk about it for a second. Let's get Desmos 3D up so we just look at it. I want to look at this thing. You want any guesses? What does this look like? Just give me a guess. No guesses? Thinking like a hilltop. Oops. Oh, well, it's it's the bottom of a valley. I was kind of close. Okay. So, and the point 3, 4, When I plug in 3 comma 4, so let's help me out a little bit here, right? So that would be 9 and 16 and then 12. So 9 plus 16 plus 12 because I'm just crude like that. Look around. Where's my point? Oh, you're right. Okay. You found it? No, that was just a 10 being weird. There it is. There. See how it's on? Okay, okay. Can I just make this bigger? Okay. See how it's like on there? Yeah. So then I'm wanting to go where it's highest and lowest. That's not around the edge here. That's like going down this way, right? Or going up. And it's 180 from each other. So in a way, I kind of like need to do this. And I'm going to align my X's and Y's for a second here. Here it is. So that's X and Y. And this is where my point is. Yeah? And so I'm saying, what direction would I go to get the smallest or the highest? To me, it looks like it's at 45 degrees. Yeah? So then I would be saying 45 degrees one way or the other. Right? Or maybe like 225. So I don't know if that's the answer. I want to just, if you don't mind, can I just get it wrong real quick? Okay. See, okay, give me a second. Hold on. I can actually probably get the answer here. I'm going to guess square root 2 over 2. Right? Because we're talking unit vectors, 45 degrees, and all that kind of stuff. And it's going to say no. And I say, never mind, I meant negative. And it might not be that. To me, it looked like 45 degrees. It's probably not. Okay, that's fine. Hi, hello. So yeah, where would this be? If you don't mind, I'm going to do real quick. I know we got 1 whole minute. Hold on. I know. Well, I mean, can I do vectors over here? Okay, let's just do the point. Let's just do the point. 10 over the square root. We don't need all that stuff. Look, here we go. 10, 11. If I were to make this a vector, right? Yeah. And so that would be, it looks like to me 45 degrees, doesn't it? Looks like 45. It's not 45. We know that right now, but it looks like 45. So yeah, it looks legit, but of course it's not. It's off by a little bit. How do we know? How do we find that? We're going to do the whole theta thing here later. And then this will be our cosine and sine. On the homework, okay? You're going to remind me? Where? More? Yeah.